What's going on, everybody? Johnny Bannon here, the networking guru, and in today's video, we're starting up again our CYSA course, going over domain 1.3 of the CYSA CompTIA exam. So let me get my face out of the way and let's go ahead and jump into it. Okay, so today we're going to be going over domain 1.3.3, given a scenario, use appropriate tools or techniques to determine malicious activity, and we're finishing up domain 1.3 by going over scripting languages. So this is going to be another one of those videos where we're only going an inch deep and a mile wide. And what I mean by that is we're going to be talking about Python, PowerShell, Bash, these different scripting languages that could be a 10-hour video on YouTube on their own, just learning how to use them for cybersecurity and, how to utilize these languages to do hacking or defense or automation or whatever the case may be, with Python being a programming language that can build whole applications and web applications and stacks. But we're not going to go that deep. We're just going to talk at a level where it's exactly what we need to know as a SOC Analyst 1 to be aware of either A, the dangers of these scripting languages on your enterprise, so not giving everyone like admin access to PowerShell on their Windows computers, or B, as a tool that could help you, maybe help you index on your Splunk instances or whatever SIEM you're using, or to help you configure like DLP rules or things like that. It's going to be at a high level, holistic overview of what these scripting languages can do for you and how they can attack you. And that's it. Just enough for our purposes here on the CYSA exam. Okay, so again, we're going over programming languages / scripting, and we're just going to talk about these 6. So JSON, which again is like, it's not a language, it's really just a way we format data. It's like a standard serialization format for our data. And then XML is the same thing, just another way to format data. Like in my day job, we use XML for our config file for like Palo Alto firewalls, or for our console servers, what we call them. It's just a way for us to console on all devices. It's an XML config file. I've used JSON before to as part of the script to get information from my downstream routing and switching devices to look at interfaces, and I format that information in JSON. So those, not really a programming language, it's just a way to format data. And then Python, PowerShell, shell script. So when we say shell script there, we're talking about Bash and Linux, which again, as a cybersecurity professional, you should know Linux. You should be familiar with the Bash shell in Linux. PowerShell is going to be all Windows. So again, as a cybersecurity professional, if you're working in an enterprise, you're a SOC Analyst Type 1, you want to make sure that you have GPOs or some sort of hardening that says not everybody and their mom gets admin access to PowerShell on those Windows 11 machines, your regular user machines. And then of course, Python, a very powerful tool that we can use to help automate, to help look at things and, help us script in our environments. And the last one there, regular expressions. We'll talk about that when we get there. It's a way for us to help filter. We'll get there. Okay, so JSON. So just a book definition here. JSON is a lightweight data interchange format. It's both human readable and machine readable, commonly used to transmit data between servers and web applications, and widely used in log formats and API responses. So, that definition, what are we talking about here? It's lightweight data interchange format. Now, if I were to pull up a whiteboard, go over monolithic web architecture, and when I build a REST API and I talk to my database talks to my backend and then relays that information to the front end. When the backend relays information to my front end, whatever my user's looking at, right, that more than likely is going to be transmitted in JSON, whatever that data, whatever that information is, right? It's just a standardized serialization format. It's going to be in a dictionary format. As you can see here, we have our JSON object in these curly brackets, and we have our key value pairs. So this looks like it's from some sort of log. So let's say we wrote a script in Python to go into our var/log files of one of our Linux web servers, and we want to scrape that data from a week long, and we want to format that raw data into JSON. We can do that with the Python script, and then it makes this a little easier to look at the information in that log. So many logs, threat intelligence feeds, and REST API outputs use JSON. So here's just a couple examples like I've talked about of how we can use, not use JSON, but how we can take data and then we want to format it in JSON, and when would we do that? So parsing log files from your SIMEs, which again is that big log aggregation. Now SIMEs like Splunk, I've never done that. We create dashboards off them, but if I wanted to feed information from Splunk into another resource, again, more than likely that data is going to be formatted in JSON. Consume threat intelligence from APIs, and extract IOCs, which are indicators of compromise. So again, if we're just getting raw data, it's not very human readable, and we want to look at it or send it to another front end kind of website, we more than likely are going to format that data in JSON. So here, the example, you can identify a failed login attempt, its source, and the user involved. Tools like Python can parse this JSON for further analysis. And really, that bullet there, what I'm explaining is, I'm not creating a JSON script. I'm creating a Python script that gets data and then formats it into JSON, right? Or I'm using some sort of scripting language to parse against large amounts of JSON, whatever the case may be. So that is JSON. XML is just another formatting structure, right? It's just another way to format structure, much like JSON. But unlike JSON, it's more verbose and was traditionally used in older systems and configurations. So like I talked about our console servers at my work, they're just out-of-band servers that allow me to console into network devices. They're old. They're on the Linux kernel 3.1, right? And so it uses an XML config file. At the end of the day, if we compare these two, right? Timestamp, source IP, event type, username, and then XML has the same thing. It's just another way for you to look at data. So older systems may use XML. Some modern systems still use XML. XML can still be used in, like, I'm from a networking background, and network automation, XML is still used. If you go take a CCNP test, they're going to expect you to kind of be able to look at XML and see like the beginner, these brackets here, where it's like the beginning and the end bracket here, has that little slash. So that's XML. It's really doing the same thing for us. So we have to know about it. Maybe we're on an OT environment, right? That's like our factories, contrasted with the IT environment, which is, updated, upgraded enterprises. We're OT environment. Maybe we're working on things from the early 2000s because it's such critical infrastructure we can't update, and those systems all may use XML. And you've been hired as a cybersecurity guy or girl to analyze and protect that OT environment. More than likely, some of those systems, when I say more than likely, definitely will be using something like XML to format data. But again, high level, they do the same thing. They're used to format data. Okay, Python. So again, it's like, man, this guy made one slide for Python. And yes, because it's one little subsection of a domain in the CYSA exam, we're looking at this from a high level. So Python is a programming language that can be used for an array of different things. I'm in a networking background. I use Python with the NetMiko library, the ParaMiko library, the Napalm libraries to do network automation, to do infrastructure as code. One of the key programming languages I use to do that. Now, at a high level in cybersecurity, we can also use Python for the exact same thing, to automate things like parsing through our logs, parsing through our SIMEs, and repeat automated tasks. Python can be part of a lot of our playbooks for remediating, part of our incident response. So it's very versatile even for us. So here the bullet point says Python is a versatile, high-level scripting language with a massive ecosystem of libraries. Very true. And is de facto standard for automation, log parsing, malware analysis, and threat detection in cybersecurity. So again, in cybersecurity, for the most part, at this level, CYSA, we have to understand Python, what it's used for, and how we can use it. Because you may fall into a big SOC that says, hey, go run that Python script weekly, right? Which is like, you should have a cron job that's running it for you. But let's just say like you need to make changes to it. Hey, we added 2 systems or a couple more containers. You need to go update that Python script to include those containers. We don't have like dynamic libraries, right, for our updated infrastructure. So that's what it can be used for in cybersecurity. So automate repetitive tasks, query APIs, create custom detection scripts. So again, maybe we're working in an enterprise with a firewall that's not next generation. Maybe we can run some Python scripts to look at those IDS, IPS logs on that firewall. Integrate with SIMEs or create standalone tools. Python is also used in malware analysis, machine learning for threat detection, and creating custom alerting mechanisms. Now again, I'm just looking at this from a high level. You just got to know what Python can be used for. It's the scripting tool that we use to parse through those log files. It's what we use to automate repetitive tasks. And the great thing about Python is like it's not system specific, where like Bash scripting is Linux, PowerShell is Windows. Python can go to all three of those operating systems. When I say three, sorry, like Mac OS too, Windows, Linux, Unix systems. Okay, PowerShell. So this is the Windows task automation scripting tool. If you go talk to any system administrator worth their salt and they work in a Microsoft environment, more than likely you've seen this blue screen before. Now, obviously nowadays they should be on Visual Studio Code and a nice IDE, but I'm not trying to digress too much. What do we need to know about PowerShell for the CySA exam? So PowerShell is a powerful task automation configuration management framework built into Windows. It provides direct access to system internals and Windows management instrumentation, so WMI. So what is it? PowerShell is the tool we use to automate and script and work within a Windows environment. It's very powerful. As a system admin, we use this tool to deploy GPOs, to set GPOs, to do updates, to invoke commands, to create Active Directory users in bulk, to get processes, to do analysis on a system. There's so much we use PowerShell for. Now, as a cybersecurity administrator, and not on the offensive, I'm talking defensive, how can we use PowerShell? For a lot of the same reasons we use Python, to automate those digging into like Windows Event Viewer, to do account audits. We can make a PowerShell script to do account audits to say, when's the last time this password has been changed, right? We can do this as part of our threat hunting, using this to threat hunt on our Windows machines. We could do this as part of our like sandboxing or our exercises where maybe we try to exploit our Active Directory domain controllers using PowerShell. And then on the defense side of the hardening part or piece of this, right? Because in our defense in-depth approach to or protecting our organizations, we want to harden as well. We probably want to limit access to PowerShell. So make some sort of processes or systems that say only the schema admins, the tier 4 domain level admins get full access to PowerShell and all of its tools, and maybe lower level admins don't. Or like if you're a network admin, maybe you don't have admin access to PowerShell. So we'll go over some of the definitions here: analyze Windows event logs, hunt for malware, suspicious processes, extract system artifacts, and automate incident response on Windows hosts. PowerShell can also be used in post-exploitation, making it crucial to learn from both defense and offensive perspectives. This is just an example of how we can get a process right on a Windows machine using PowerShell. You can see their commandlets here: get process, pipe out, look for an object, and we're looking for something called app data. And then here we pipe it again to format it. And this format table makes our output more human readable, and then it gives us three things we want to know: the name, ID, and the path. So like installation path, the process ID, and the name of that application we're trying to look for, right? Or that suspicious process. Okay, shell scripts. That's what they called it in the exam objectives. It's Bash, right? Everything I just talked about with PowerShell, everything I just talked about with Python. Now, if we're in a Linux environment, that's the Bash shell. We can do shell scripting in our Linux environments. So shell scripting, commonly Bash in Linux environments, lets you automate command line operations and parse text-based logs or configurations. It does everything that, not everything, right? Because Windows and Linux systems vary. But again, at this high level that we're learning, it does the same thing. We want to parse through logs. We want to automate cybersecurity tasks, doing file integrity checks, hardening. We all do it from the Bash shell. We can schedule cron jobs to launch certain scripts. It helps us in our incident response, be part of our playbooks for automated remediation of incidences. So shell scripting is essential for threat detection and automation in Linux-based environments, including servers, our security appliances, and pretty much anything that's Linux-based. You have this ability to do Bash shell scripting built into it. Now, again, the typical user is not going to be, hopefully they don't have access to your, the CLI of your web servers, but it is something we want to lock down. So maybe we do have something like Security Enhanced Linux that locks down the Bash shell script to at least not give someone, the ability to get into root from the CLI. So there is also that hardening piece to this as well. Okay, then regex, or regular expressions. So regular expressions are search patterns used for matching text strings, exact text strings. Regular expressions can be used in Python, PowerShell, SIMS. It can be used in shell scripting. I use it on my Cisco CLI. If I'm in traditional networking environment, Cisco CLI supports regex when we look through our running config. So it can be used to detect patterns. It can filter data streams. And if you're good at regex and you're not using AI or some sort of online tool to build your regex expressions, good on you. You're a savant. Probably a little TISM in there as well. Not to be, but we're learning regular expressions. Wow, that is tough. And here is just an example of something we do in networking if we want to match an IPv4 address. So we import regular expression library into our Python script. We make this variable log, and then we want to search on that variable. Here's how we find an IP address with its 4 octets, right? So you can kind of see here, hey, this is a number 0 through 9. It only can go 1 to 3 and then separated by a dot, right? When we say 1 to 3, it's only going to be 3 numbers. So you can see, the difficulty here and just looking at regular expressions. This is how regex filters for an IP address, right? And then you can use this pattern in tools like grep. So grep is in Linux if you want to grep's pretty much like, let me search for this keyword or this, this text string in this file. You can use it in Python or other log filters. Okay, so conclusion. So again, to tie it all together, because we looked at this from a high level, understanding and utilizing these languages and scripting techniques provides cybersecurity professionals with the tools to automate, investigate, and respond to threats efficiently. So just a quick recap, right? If you learn nothing and you're preparing for the test, let's look at this slide. So JSON, log parsing, API communication, XML, extensible markup language, JavaScript object notation for JSON, XML, older log formats, configuration parsing, Python, automation, detection scripting, API analysis, PowerShell, Windows artifact analysis and incident response automation. It's Windows though, keyword. Shell scripting, Linux log parsing, and task automation in a Linux environment. And then regex, or regular expression, it's indicator of compromise detection and pattern recognition and helps us, something we use in our scripts to help us parse, right? Okay, now let's go ahead and do our quiz. Okay, so we're at our custom learning management system here, and I'm going to go to our CYSA course, and we are doing domain 1.3.3. I'll come here to my lessons, come here to domain 1.3.3. Let's scroll down here, and let's go ahead and take our domain quiz. I'm going to zoom in for us here. Let's do it. So question 1. Which of the following formats is most likely used to transmit log and event data in a modern web-based SIME platform, Security Information Event Management Platform? So our answers here: A, YAML, B, CSV, C, XML, and D, JSON. More than likely, I'm going to go with JSON here. YAML, yet another markup language, another way to format data, is not typically used for the transmission. CSV is like Excel, comma separated. Oh man, that's horrible. I forgot what it stands for. But it's like Excel, it's spreadsheets. Then XML, simple markup language, is used in older systems, but we are in a modern web-based SIME platform. So we're going to go with D, JSON, JavaScript object notation. Question 2. You are analyzing a Linux server for signs of brute force SSH attacks. Which of the following bash commands will count the number of failed login attempts? Failed SSH login attempts. Okay, so looking at failed login attempts, so B is out of the table because we're doing tail here on our auth.log file, and we're grepping for accepted password. So obviously we can rail that, get that out of there. And then I'm looking at A and C here, where we're doing cat var log secure. That's usually not the file where we have login attempts though. It's usually in that auth.log file. So I'm gonna rule out A. That's like a good way to do it, like the way it's at least parsing through that data, but I'm gonna get rid of A there because that's not the file. And then D, find, the cat command is not what we want to use. It doesn't have the full path there to the auth.log file. C does. It's like the full path, right? So I'm going to go with C, grep. And then, that's like regular expression right there, even failed password. And then we're looking in this file with the complete path. So I'm going to submit, and yes, it's going to be C. Okay, question 3. Which of the following regular expressions correctly matches an IP address? So we just looked at this one on our slide deck. So again, like I was saying, regular expressions, not the easiest to detect, but it's going to be D right here. Let's go look at our explanation and show why. By matching 4 groups of 1 to 3 digits. So this is 4 groups of 1 to 3 digits separated by dots. So you see separated by those dots there, with word boundaries on both sides to ensure the address isn't part of a larger string. So pretty much saying it's just numbers. So we're looking for something that matches like this, right? C would also work, but you see here, this is very simple. It's just looking for numbers 0 through 9. But here in these curly brackets, we're saying no, the numbers can only be up to like 255, okay? So option C is overly simplistic and may match invalid patterns such as 9999.999. Okay, question 4. Why is PowerShell particularly valuable for cybersecurity analysts working in a Windows environment? So I'm going to go with C here. So it integrates deeply with Windows internals for system and event log inspection, right? It's the scripting language for Windows, right? And all right, we got 100%. So I want to thank everyone for viewing. Make sure you like, subscribe, share with your friends, and I'll see you in the next video.